A satellite of mass m is orbiting around a planet of mass capital M. Let's say this is Earth, whereas this satellite was at a distance of r and it is orbiting around the Earth with a large speed in this orbit. If this satellite has to move in the other orbit like this, in which the distance from the center of the planet is 2r, then in this question you have to find out how much work is needed to move it into the orbit where the distance is doubled. So let's first of all see what is the total energy of the satellite, because this satellite is moving around the Earth. It have the kinetic energy due to its motion as well as gravitational potentiality due to its position from the center of Earth. So I have already derived it here just for a reference, that how do you get, if you solve this, you will get the total energy at this point in this first orbit is negative gmm over 2r. This is negative due to the attraction of the satellite by the Earth. So we can assume that this is the total energy initial. When this satellite will move into this orbit, where now it will have a total energy final, will be equals to negative gmm over 2 into orbital radius is 2r. So these are the total energies in these orbits. So work done according to work energy principle, that the work done is always equals to the change of energy. So you have to do the final energy minus initial energy. So if we plug the values, then it will be negative gmm over 4r, that is the final total energy, minus into, here we must take the LCM. We can make this thing, if we multiply by 2 in numerator as well as 2 in denominator, this will become 2gm. Capital M is the mass of planet, small m is the mass of satellite. Here we have 4r, taking LCM 4r, adding the numerator, negative gmm plus 2gmm. So you will find out you will end up the value that will be positive gmm over 4r. This is the energy required to move it from the one orbit into the other orbit, where it will be moving slowly. So the right answer is option C.